Good morning, guys. Welcome back. We will continue with our AWS session. So today is AWS day 4 session, and today the date is 24th of November 2025, and the timing is morning 8 a.m. IST. So, guys, before we start with today's session, let us try to see like what we had did in a day 3. So day 3 basically we covered about the concept of some of the region and availability zone, right? So region is something, it's a geographical location, right? Where like they're going to set up the data centers, and basically in a particular region. So by the way, as I said yesterday, in last session that or in the day 3 session, region is not a country actually. We cannot say region as just a country, because a region is a place where you set up the whole data center actually, and within a region you will have more than two or three availability zones actually, and all the or what are the availability zones are there, right? Those availability zones are interconnected with the strong optic fiber network, which is laid down by the Amazon itself, and that is called as a backbone network, right? So this is what we had discussed in last session. And also, like, we had discussed about certain things about I think that much was pretty much which we had covered, right? This is what we had covered it. Like, yeah, yesterday was, we had just a small session, right? That's what we couldn't continue further. Fine. And also we discussed about what service and resource all about. So this is something which we discussed in yesterday's session. Okay, what we are going to do today. So today we are going to start with the basic of networking, because we will be starting our AWS networking stuff. Hence, I need to cover some few basics of networking. Before we start that, like in last session, I told that actually that whenever we are having a region, right, and basically we are having so many regions actually, right? There are more than 120 plus regions are available, right? So now, whenever we want to choose a particular region, what are the best practices you follow for choosing the region, right? So now the thing is that whenever you get any kind of a new customers where you need to do some kind of a migration activity, or you want to do some kind of a setup for in the cloud environment, basically what happened are you design it completely and you come up with a plan of like how you are going to go with the migrating the application into the AWS cloud. So one of the main important parameter what we choose is that choosing a region actually. So most of the time, the region where the particular client comes from, we will try to migrate under the same region. Say for example, if you find any customer who is from US, we will try to assign the region from the US itself. Actually, right? We have four regions. There are four availabilities. Regions are there. Basically, you have a Northern Virginia, California, Oregon, Ohio. These are the four regions which are there in your US. So you can choose any one of the region for the migration activity. Okay, and also within the region, guys, every region there are different services are available, right? Uh, what AWS do or what Amazon does, that whatever the services which are there, like more than 200 plus services are there, these services are almost available in most of the regions actually across the globe. But sometime what happened at some of the region, some services are not available. Okay. Say for example, if you come up with some Africa region, in Africa region there are many in Africa content there are many regions are there where they have set up the AWS data centers. In some of the regions, what happened at some services are not available. So when some of the services which are not available, if you need it actually, then you need to raise a request to the support engineer. So they will check on that and they will check the feasibility to provide that service. If in case for some business reason or for some other reason, if they're not able to give that service in that particular region, they will straight away say that okay, we will not be able to give this reason with this services in that particular region because of so much constraints actually. So they might have some business reasons for not providing some services, but I don't think that AWS will say like that. Amazon basically what they do, that they will at most try to give all services in almost all the region. Some services, if they are not available in particular regions, right, if you request them, yeah, they will provide the service to you in that region. But you need to you need to contact the support team, and you need to have some kind of a plan which you are working on. So say for example, if you're going with the enterprise plan, right? So enterprise plan where you are paying some no, you are paying a hefty amount to the Amazon, right? Amazon definitely will try to provide you that service, right? If you are going with the enterprise plan, it depends upon the plan which you choose. Based on that, they will think like whether we need to give that service or not. But as I said earlier, right, at most I see that 90% of the services are available in almost all region. Now that is one thing. And the second point, very important, is that guys, like whenever Amazon develops any kind of a new services, right? Every year, you know that Amazon or Azure or GCP, right? These people, they try to come up with a lot of new services actually, and then we keep adding these new services, right? Now the thing is that when they add any new service, what they do basically, right, they want to do all kind of a testing, everything, making that service available only in few regions only. For example, Amazon, what they do that when they try to come up with new services, what they do that they try to have the new service available in the US region only. Like for example, in Northern Virginia, in Ohio, or else in Oregon, or else in North California, some of the new latest services will be available in that region only. Those services will not be available in other region for some time. Say example, for example, in Japan, you need some in Tokyo region. There are some clients who are using that Tokyo region, and they need that new services which is recently which has been released by the Amazon. So that might not be available in the Tokyo region. So again, what happened? They need to raise a request to the support team, and they check the feasibility, and they want to, they will let you know that when that service will be available. Basically, what happened? Whenever the new service comes, they'll also give the timeline also, like when these services will be available in all the regions. Say, for example, in India region, you need to provide that service. So they will say that, okay, in this particular region, this service is going to come in next 30 days or 45 days. Like that, they will mention in the official documentation. You need to go through it. You need to understand, okay, this new services will not be available from this to this time, and it will come up on this time onwards. Like that, you will get a notification also, and on the official document also, they releases all those notes. So you need to understand that, guys. So when any new service come, it will not be readily available in all the regions. Actually, it will be available only few regions. Like in UK region will be available, or in US region will be available. When it comes to Europe, yeah, in some Europe regions it might be available. In some other Europe region, it might not be available. It might not be available in Asia Pacific. It not be available in other countries like in Australia, or it could be not be available in some of the eastern countries like Japan, Thailand, and it will not be available like that. So it depends upon the release dates when they are going to make that service available. Now the thing is that why I'm saying all these things, because guys, like if you are going with any kind of a client request where you need to set up the whole like the whole setup you need to provide in in your AWS cloud actually, then it has become very important to choose a region also. Sometimes the customers might needs a lot of new services which are provided by the cloud. So in that way, what happened? You have to choose a region where most of the resources or most of the services are available, right? That is the main important point. And the second important point is the cost actually. Cost is something which plays a very vital role, because every region, what are the resources we allocated, the cost may differ. So region to region, the cost may differ. So what we do that, as I'm a cloud architect, I need to best give a solution to my end customer where there will be a lot of huge cost reduction also will happen. I have to give him the best plan and the best option. Okay, so that what happened, right? It will reduce the cost for the particular client actually. So that is one of the very important criteria, right? Whenever we try to choose any region, right, we also checks the cost also. Sometimes what happens, some customers are from US, okay, and they need to do some migration, but when you give a plan for migrating everything in Northern Virginia, and when you see that actually the service cost is high, and if you see the same service which is provided in UK, like for example, you have a in UK you have a Stockholm, or in London you have the London region. There, if you see, right, maybe there the cost might be little much reduced compared to the US region. So you might give an option to the customer saying that, okay, if you're going with the Northern Virginia, this is what the end of the year we are going to get the bill, or this much will be a monthly payment bill. And the same thing, if you are migrating everything into the UK, right, you might get this much of reduction actually. So again, what happened? We will finalize this plan along with the client, and the client will agree with whatever you put up the proposal. So based on the cost effective also, what happened, the client will think over, okay, whether we can go with UK or not. right? So they are only worried about the latency part. That's what latency means, how fast I can access my application or how fast I can transfer the data actually, right? Because the US client might be sitting in US actually, but when they're interacting with that application, that application is hosted into the UK region, right? From US to UK, it is not that much far, but still, what happened? There is some distance is there actually, right, between one region to other region. So they'll also think about the latency also. So as being an AWS architect, I need to provide all kind of information regarding the latency test also, like how fast you'll be able to access this application, how much time it will take. Say for example, if you're hitting any URL or if you're hitting an application, okay, through your browser, so you will say that okay, you will get connected with your application in 3 seconds, like that something. Okay, in 3 seconds, your application will be loaded actually, right? Sometime what happened, right? Some customer you say that okay, sir, I will be using some region where the cost is very less. Say for example, I will go with somewhere in some Europe region where the cost is very much reduced. But what happened? The latency it is taking is little high. Like for example, if I try to hit an application, it is taking around some 6 seconds to load that application. So in that case, what happened? The client will think, okay, for me, right, cost is also very much important criteria. Along with that, even the latency also very much important. But yeah, if the application, if my request is taking some few more seconds to get connected, I'm not really worried about that much. Okay, let it take some 6 seconds to load my application, or let it take this much of time to copy the data from the US region to the particular Europe region. So if you are okay with the latency test, with maintaining all the data and everything, if you're okay with that and you are compromising in that area and you're okay to have an application all placed everything in some Europe region, yeah, it's all left again to the customer end actually. If he's okay with that, yeah, we will go with that Europe region only. Again, it's all depend upon the cost, guys. Actually, it's all depend upon the cost, and it depends upon the infrastructure size also. Suppose if a client is setting up a huge infrastructure, right, very big infrastructure where they're having hundreds of virtual machines, lot of VPCs is creating, lot of accounts you need to maintain it, a lot of load balancers you are using at your work, right, and so many different services are used, highly paid services are using. You are using a lot of highly paid security led service you're using. So when you are using such a big infrastructure and like every month there will be lakhs of rupees of billing will goes on. Of course, in that case, what happened? You need to even think about like how best you can reduce the cost also, right? And guys, I had worked in some previous organization. I'll not be naming that organization. What is the name? But when I worked with them, they had maintained around six AWS account and few Azure accounts and few GCP account. They were maintaining it actually. And when I checked out in the cost billing or what is the cost they are getting per month bill according to the Indian rupees, they were getting around 26 lakh rupees as a bill every month. Paying 26 lakh rupees, of course, that whole setup was very much complex actually, right? They were using Kafka services, they were using Debezium services, they were using Databricks actually, which cost very huge, and they were using very very big large servers they were using for like for running their applications, for running their databases and everything, and they were using almost most of the highly paid services they were using in AWS actually. So when I checked it, actually, yeah, the business need is required you to use all the services. That is there, no doubt in that. Because without that, like they cannot run the business. They cannot run that. They cannot run that business. So they have to use all those services. But the point is that, like actually, that is there any way to do a cost optimization with that project actually? So usually what happened, right? Like they will calculate. We were calculating like okay, where exactly the more like bill were coming actually. So the every day what happened, right? You might have not know about the Databricks actually. Okay, like when you hear about something like the AWS data engineering, you will come across with something services at Databricks actually, and Databricks is a solution which is provided by the Databricks company, right? And I don't want to really go in detail about what is Databricks. So Databricks is a pretty expensive service what we use it actually. So they integrate the Databricks with the AWS cloud and you can use it actually. And Databricks itself has a right, you can write a pipeline. So what I saw in their projects are every hour, guys, the Databricks pipeline will get executed. It transmits the data from one source to the from source to the destination. It transmits the data. For that, what happened that they had written a very big pipeline they had written actually, right? So then what happened, right? That pipeline was consuming too much of resources. It was creating, a lot of servers. It was creating for just doing some transmitting the data. After it done, actually, every hour some big server is to get very big instance it is to get created when the pipeline is getting executed. And then what happened, right? That was consuming huge bill actually, and after 1 hour you could see that the same server is getting destroyed. Every hour they were doing, even 24 bar 7 365 days they were running the pipelines actually. And I don't know like why they were, right, why they were actually doing that much of computing. Why they're doing, I didn't know actually. So that is what they, it could be their business requirement. That's what they were doing actually. So the thing is that actually that now the point came that actually how you can reduce the cost. So you can reduce the cost in the Databricks itself actually. So what happened? Databricks teams, they were involving the Databricks teams along with the AWS team were involved. So one of the engineer from Ireland, right? He had joined the call. So he would become a support engineer from the Amazon side. We got two people from Databricks side. They understood our entire application and the architecture. AWS Amazon people, right? The engineer from the Ireland, right? He connected with us and he was trying to see the whole thing, like how we were utilizing all the services of the AWS, okay, which is necessary, which is not necessary. So based on the discussion, right, they had given some few points to us that like where we can go and reduce the usage of these services and all, like so, and also how you can fine tune your Databricks pipeline so that no, it shouldn't create that big server. Instead of having a big server, let us go with some little bit smaller server. So like that, what happened, right? We arrived with the conclusion, okay, by doing all these practices, best practices, we'll be able to save so much of cost actually. So that was one use case actually, and saying is very simple, guys, right? But implementing, doing the testing, and making sure that your business doesn't go down, because when you're experimenting something, you might do in some other environment, but when you're applying all these changes into the production environment, right, things might get fail actually, and you cannot take any risk of making your production to be down actually for some time. So what happened that when you are doing a thorough testing, you will try to do thoroughly testing in 2 3 environments, low environments, like in dev environment, in stage environment. Once you are completely certify saying that okay, everything is fine, okay, there is no issue, then only you will go and you try to do the same changes in production actually. And production, you need to know, you should be very smart enough to make sure that if the production, sometimes the production goes down, you should be able to recover also actually. You should be able to you should be able to immediately revert back the changes, so that actually there will be a continuous flow. So all such plans and activity you need to take care, guys, when you are doing the changes actually. So one of the criteria, as I said, right? So there, what happened, guys? Why I told all these things, because there were two important things which came into the picture now. Now, one is the region which we selected, and one is the services which we use it actually, right? And what kind of an architecture we have come up for our entire project requirement actually. Okay, which are necessary service, which are unnecessary services which are using in our project. How we can do a cost reduction. Okay, how we can do a cost optimization, we say, right? Once we do a cost optimization, we will come up with a plan. Okay, this is the service we need it. Okay, this service we don't need, will let us reduce it actually. Say for example, like there in our old project, right, we had some 6 Kafka services for use actually. And we were thinking that why exactly we need 6 Kafka? Can't we make it to run under the 3 Kafka itself? We came up with a plan of how we can reduce the 3 Kafkas actually. So we reduced the 3 Kafkas, and with the remaining 3 Kafkas only, what happened? We were able to do all our project flow work actually. And again, what happened? Right? How you can reduce the cost of Databricks? That was also discussed. How we can reduce the cost of syncing of the data. So sometime what happened, every day we were taking a backup at the end of the day, right? From the Northern Virginia, we are taking the backup of to the Stockholm region actually. So we were thinking that why we are taking so much backup, and when you're taking a backup, like it is going and storing in your GP2 storage. Can't we archive and send it to the Glacier so that our cost also reduces when it comes to storages? All such things we had a plan actually. And then like we came up with a proposal, okay, this is can be done, this can be a better solution for us, and that's how we will be able to reduce the cost actually. So we came up with such plan, and management agreed, and all stakeholders within the organization, right, the different teams who are involved in the project, right, even they all have to sign off actually. Without them signing off, right, you cannot go with any kind of a modification in your account actually. So you need to take a sign off from all the teams. You need to propose a plan. You need to create a PPT, and you need to you need to give a presentation in front of all the team. So they might have a lot of cross question. They will ask you. They will give some other ideas. You need to even listen to their ideas, and then you need to tell about like what is your plan, how your plan is best compared to all other people who have given the idea, right? You might incorporate some other ideas given by some other team. Okay, later you will improvise more in that, and finally you will come with the exact concrete plan on how you will go ahead with the cost optimization. Once the plan once it is agreed by all the stakeholders and the team, then you will send an official email. Then you are going to create one Jira ticket in that for that proposal work. In that Jira ticket, all the stakeholders managers have to sign off. They have to be present. They have to sign off. They have to say yes, 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 we agree with this plan. Then only you can go and start. You can go and start going. You can just start going with the optimization actually, right? Once the optimization is done, again you keep track of your cost estimator. You will see a monthly bill how much you're going to get. So once the monthly reduction start reducing it, so even like your Databricks team who is supporting you, they'll also keep monitoring about the cost of how much it is reduced. Even your AWS support engineer, Amazon support engineer who has been assigned to your project, right, he will also keep track of everything, so that you will see there will be reduction in your cost every month. So these are some better plan, guys. So I will take one session on how to do cost optimization. I will give one scenario and I will tell about like how we can do cost optimization. So that same example you have to tell in the intro that this is how I involved in doing cost optimization. And there is a lot of ways are there, guys. Sometimes what happen, right? You can even change certain plans to do cost optimizations, right? You can even go with some other services, okay, for reducing cost optimization. For example, you might use code pipeline or core commit. These are the developer pipeline tool you might use in your AWS itself, which might be costing huge. Instead, what happened, right? You will come up with a plan saying that, okay, let me go with an open source tool, something like a Jenkins or GitHub Actions. So instead of running the pipeline through the AWS, let me go with this so that it will completely reduce my entire, it'll reduce my cost which is involved for the pipeline actually. So sometime what happen, you will go with that also plan also, but you will see the feasibility, because when you are running the pipeline everything through the cloud only. Say for example in Azure you are running the all the pipeline through Azure DevOps actually. It has a very good it doesn't have any kind of a big impact for your business actually, because AWS DevOps is a service we provide with AWS. Azure DevOps itself is a service we provide with Azure DevOps on Azure itself actually. There are a lot of advantages are there, guys, when you're using Azure DevOps actually. It will become very easy for you to develop, manage and maintain all your application stack, everything in the Azure itself. Suppose you incorporate some other tool at that time, what happened, right? It might lead to some complexities, right? So if any complex issue happens in the near future, somebody there should be there in a team to fix that issue. So that's what happened, right? We will go, okay, sometime what happened, right? Okay, if it has some kind of a cost, it takes some more cost for me to do it, but that is fine for me. I'm okay with that cost. I can bear with that cost. Right, because that my business, right, my development activity and the business should not get impact, right? So sometime what happened, right? You will go with, okay, if that is little bit costing more also, I'm fine with that actually. But I don't want to go with some other solution which will have a greater impact, or it might impact my business, or it might impact the entire development activity. It might impact. I shouldn't go. I cannot go with that plan actually. So sometimes what happened that you in between you will try to compromise certain things also. But of course, if the business is consuming a lot of bill actually, and you are getting monthly lakhs of rupees billing you are getting, yeah, definitely you need to sit and think over like where you can go and reduce the cost actually, right? Fine, guys. I think I took some time to tell about all these things, but it was required, right? So now why I told all this is because like we need to understand what are the best practices we will follow actually. We follow to choose AWS region actually. So whenever working for a specific client, as I said, right, we have to even choose the region also. The first important thing is the proximity. So proximity is something where what happened, we will choose the region where the customer comes from. If the customer is from US, we will go choosing the US region. The customer comes from Japan, you will go with the Japan region. The customer comes in India, we will go with the India region. So wherever the customer is placed, right, wherever the customer comes from, in the same region only, in the same location only, you're going to do the entire setup, because that he will be accessing his application, right? So the latency should be very, very less. It means that he should be able to immediately access his application very fastly. Within 1 second or 2 seconds, he should be able to access the application, and also transmitting the data. So the customers might have a very big chunk of data. He might have a lot of data related to his customer base actually. So he need to keep all the data safety in his region, and he should be able to take a backup of all the data of his customers. Okay, and that's the reason what happened. He will go choose to go with the region where he come from actually, right? So if you have a US client, you will not go set upping everything in the India region actually, or in Asia Pacific region, because there the latency will be more actually, right? Because whenever the application is been accessed by the client who is from US, and the application is you have been hosted in India, so it might take more time to connect, right? Similarly, you are doing a lot of communication, okay, and also the application is communicating the database. Again, there will be a little bit latency between the communication between the application server to the database server. You need to store the data into some storage device, right? And that has to be taken backup actually, right? And you need to transmit some of the important data from your one region to other region, because so that will consume a lot of time actually, right? So hence what happened, right? They will go with the choosing the near location only wherever the customer comes. That is what we call as a proximity actually, right? So what we say that we choose the region closest to your customer location to optimize network latency. Am I clear, sir? You agree with this point, right? Okay, good. Now, usually what happens, right? You can yourself test the latency. Like if you go to the Google and just say AWS latency test, you can go with this first link, right? Now you could see that if you go with the AWS latency test, actually, you can click on the AWS latency test. Mm, 1 second. Yeah, this one. Yeah. So you could see that actually, so it is performing. You could see that. See, guys, I'm sitting in Bangalore here in Karnataka, and this is my IP address. So when I want to check the latency test, basically I want to ping and check like how much time it is taking. See, for APFN South FN, like 1A, that is Lagos, Nigeria, it is taking 270 milliseconds. Similarly, if you go to the USFN East FN 1A, that is Atlanta, it is taking 250. So nearest to me is actually APFN South FN, like Delhi, right? Delhi, India, that is 69 second. Kolkata, it is taking 60 second. Okay. What about the other things, guys? Which is the very less actually for me. The less is nothing but your 63 only, right? 63 is not but your APF and South F1 on Kolkata region. This is what nearest to actually. For me, it is only taking 63 seconds actually. Milliseconds actually. Millisecond. It is millisecond actually to connect it actually. So you can perform this latency test to verify like from your region, like how fast you're getting connected, or from your location, how fast you're getting connected to this different regions actually. Like that, you will be able to perform this test actually. Okay. So this is one thing which you have to do it actually. And apart from this, you have to even check with the AWS ping test actually. Right. So you can go with the AWS ping, right? You can go with this. So here you could see that you are doing an HTTP ping, and let this check on how much time it is taking. You could see that Northern Virginia it is taking 240 milliseconds to connect. Okay, it is taking that much time. Hyderabad, Mumbai, see how much Mumbai is taking. Mumbai is taking only 92, right? And apart from that, any other thing are there, right? Yeah, this is what I see that 37 is Hyderabad. From my home, right? Bangalore, Hyderabad is very near. So it is only taking 37 seconds, milliseconds actually. So like this, what happened that you can test it out and you can verify the latency checks actually. Am I clear, sir? And the second important thing is the services. what are the services which are provided actually. Try and think what, try and think what all your most, what you can say, needed actually, right? Needed services for your customer requirement, right? So usually what happened, as I said, the newest services will not be available in all the regions. It will be available only for some few particular regions only. So at that case, what happen if your customer say that, okay, I need that service actually, can you make sure that service is available? So sometime in that particular region, it will not be available actually. So you have to go and request, you need to wait for some time also to get it, right? And the third important thing is the cost actually. So certain regions will cost more than other regions actually. So in that case also you need to best plan, right, how you can optimize it actually. Am I clear, sir? And the other thing is that actually that one more is there, no, just service level agreement. Service level agreement, we say SLA. So what in by service level agreement, guys? Service level agreement is something like it's just like a cost only, right? It's just like a cost only, right? It's just like a cost only, right? So usually what happened, right? Whenever we go with set up the whole thing in our AWS cloud, actually, we will have an agreement with our Amazon company saying that actually, okay, I'm setting the whole the my whole project, my whole infrastructure setup, I'm setting in your AWS account actually. Okay, what kind of a service level agreement you can provide us so that at any cost my application shouldn't go down at all my data, or you can say that the data redundancy will always be allowed. It means that I will not lose all my important data. My major customers' data are available in AWS database. But assume that if and that in the back end, if the database goes down, so who's going to take the responsibility? Right. So Amazon has to take a responsibility, right? So Amazon has to sign off saying that actually that like we will provide 99.99%, we will try to provide the complete data to you always. The data will not be lost at all, right? And also what are the service you are taking, right? We will try to give all the service always available 24 bar 7 365 days. We are going to give that service. That kind of a SLA agreement they will try to have with the particular customer. Suppose in case if the customer, if he sees any kind of a downtime in his application, right, due to some issue or error issue from the Amazon itself, according to the SLA, right, what happened? The Amazon has to pay back the lost money. What are the money which has been lost from the customer, right? He has to pay back that money, and that cost is very huge actually. It goes with millions of no rupees. It goes with millions of dollars actually. So even like for Amazon also to maintain all such things, right? It is a quite challenging stuff for them. So that's the reason what happened, right? They'll always have a backup of all the data and everything, so that they're not losing the data, the customers, data and all. And also they will suggest many plans, everything to the customers to go with going with some services when it comes to security, to go with the setup and the disaster recovery setup actually. They will try to go with a proposal to the customers actually. Again, it is left to the customers whether he want to go with the disaster recovery or not actually. So obviously what happened at most of the customer in today's time, right, they are going with the disaster recovery, because if something happen in one region, they'll be able to quickly get the business up and running in from the other region. So that's what they will set up the disaster recovery also. This would be also be suggested by the Amazon, saying that you need to go with at least minimum one disaster setup or else multiple disaster setup actually. So it depends upon the business which they are running. It depends upon that how much they can spend the money, right? And all such factors comes into the picture, guys, whenever we are setting up the DR actually. So DR has become very, very important. It is also kind of one environmental, like how we have production environment. Even disaster recovery, DR also has become one of the environmentally now actually. And you need to have a separate resource to manage the DR also always actually, right? You don't know, right? When no your site might go down or when your application might no go down, we don't know, right? So hence what happened, you will have a different set of the same infrastructure setup as a disaster recovery in other region actually or nearby region actually. right? So that service level agreement will always have a agreement with the Amazon. Actually, this is also one important thing. Actually, you have to tell all these points, guys, when you're giving, when you are, like when you are talking in front of an intro, right? And the last is not but the complaints actually. So complaints is something like you need to meet some kind of a regularity. See, for example, if you are having a US client, right, and when you are migrating the your application, everything set up, everything in your AWS in your US region, you need to follow certain kind of a guidelines or the regularities which is proposed by the US government actually, right? So maybe what happened that you might be running your complex medical care applications in your AWS. You might be running some very big financial based applications and everything in your AWS actually. So you need to what I say you need to meet some kind of a regularity complaints, right? By hosting your application in that specific region or in the multiple regions actually. So that complaints you need to always obey it actually, right? So for example, something like there is something like a GDPR is there. GDPR is one of the complaints actually or the regularity complex which you need to agree, right? Which you need to agree actually, right? So those are certain things where some kind of a projects where it becomes like a threat to the nation actually. Like for example, some different projects, defense related projects are there which you are managing, or else you are managing some healthcare projects actually, right? Or else something like you are managing some very big financial based projects actually, right? So then what happened, right? This all this GDPR regulatory compliance all will come. You need to sign off with Amazon. Amazon also will make sure that to keep your data, everything in a very secure and a very protective way, actually, right? So those things and all have to be managed very well. These are some best practice, guys, right? There are many other are there, but I think that this much is sufficient for us. So you can tell these 5 points in a front of an interview. Am I clear, sir? Okay, guys. So this is what I have to discuss. Okay. Now, what are the things which we can continue now? So, guys, now since we are discussing about the AWS services. So we'll first go with the AWS networking, as we said, right? In AWS networking, we are having more than 10 to 12 services are there. We will go one by one those services, as well as we'll be doing a lot of practicals also, right? But before we start with AWS networking, guys, I have to little bit discuss about some basic aspect of the networking part, basics of networking. So I know many of us know about the networking, right? Because we have been working from long time. We have some basic understanding about what is networking or what is network is all about, right? We have also come across with many kind of protocols, networking based protocols, right? And also we know that actually, like when it comes to working with the system, okay, in the back end, everything works is nothing but networking only. Suppose you are connecting to one system, right? You want to connect to one system, or you want to communicate from one machine to other machine. Yeah, you need a basic networking is required, right? And also like you need to know about the protocols what are used for doing this communication. So what I would suggest, guys, at this point of time, like let us try to discuss some of the things about the basic networking aspect, right? We will try to understand that, and we will try to understand some basic terminologies what is used in the networking, that we will try to familiarize with all those terminologies. And we'll also try to understand about some basic things like what is an IP address all about, what is public IP address, what is private IP address, what are the different class of IP addresses are there, what is subnetting, okay, what is natting, what is subnetting, okay, what are for example protocols, right? You have a lot of different protocols are there. We'll discuss about something about protocol, and also we'll discuss about some kind of a servers are there. Like for example, you have a web server is there, right? Or else proxy server is there, or else reverse proxy server is there. So many things are there in networking. We will not be able to address everything, guys, but few of the things we'll try to understand, because this will be kind of our no this is all our basics knowledge what is required you to learn any kind of AWS services. In when you're learning AWS networking, it is always better that your all your networking concepts are clear actually. That's what I thought, that let us try to get into some basics of networking, so that we are well versed with that, and then like we will go with the actual AWS networking services, right? When we try to learn it, we'll be able to understand in a better way, right? Now, the question comes, right? Whenever we come with the networking, guys, there are two terminologies we always come across. One is nothing but the network, and other is networking. So always we come up with these two words, network and networking, right? Now, what is this network is all about? See, basically, guys, suppose for example, if you are having some devices, like for example, you're having two servers, assume that you're having server one and server two. There are two servers are there. Consider this as a server one and this is server two. Now, whenever these two servers want to communicate each other, they need some kind of a physical connection is required. So if you go with some networking cables, actually, you will get some networking cable. Okay, right? You connect that networking cables, and what happened that you will have a physical connection from this server to this server. This is nothing but your network cable, coaxial something with RJ45 connector. You will use that RJ45 connector to connect it. So using this cable, what we do basically, we will try to set up a physical connection between one server to other server actually. Right. So whenever there is a physical connectivity between these two devices, we call that as a network actually. We call that as a network. Like here, it is a physical connection between two devices is called network. Right? Correct guys? Do you agree with me? Okay. Now, if network is something where we say that, okay, it's a physical connection between two devices called the network, then what is networking is all about? So networking is something like it will take a help of this network. Okay. Take the help of this network means take the help of this physical connection, right? And then what happened? These two devices or these two servers can able to share the data between them. Like server one can send a data to the server two, and server two can send a data to the server one. So whenever there is a transmission of the data between these two server, that we call it as a networking. So here what happened, right? Uh, if if there is a if there is a transmission of the data, okay, if the transmission or if there is any sharing of the data between two devices, using some protocol, we call then we call it as networking. Am I clear, sir? So with the help of network, when two devices share the data by using protocol, then we call it as networking. Am I clear, sir? Say, for example, here, consider this itself actually. For example, like you have some two machines actually. You have two some servers. Okay. You have some two virtual servers. This is one virtual server and this is another virtual server. So you're having some two virtual machines, VM1 and VM2, like this. So guys, whenever we want to do, whenever you want to set up a physical connection between these two devices, you can have a single cable like this. You can connect over that single cable with one machine to other machine. right? So when you can do this physical connection, when these two servers are very nearby, they are something like these two servers, if the distance between them is less than some 30 meter. Like for example, one machine is there in first floor and the other machine is in second floor, right? And there's a distance between them is less than 30 meters. Yeah, you can definitely go and take a physical wire, the coaxial network cable, and you can go and connect it. It will work actually. But yeah, right. But usually what happen, right? Many times what happen, right? Your virtual machines will be far off. The distance between them will be very far actually. There will be more than 30 meters actually. So in that case, what happened, right? You need to have some kind of an intermediate device. Okay. Through that, you can connect these two machines actually. And that intermediate device, we call it as a connectors actually. We call it as a connectors, or we call it as a gateway actually. So here, what happened, that you will be having one gateway like this. You'll be having one gateway actually, right? You'll be having this is what we call a gateway actually. So this way gateway can be anything. The gateway can be anything, guys. The gateway can be something like you have something like a router, right? You have something as a router. A router. You can have the router. You can have a switches, right? You can have some kind of a firewalls. Some connectors are available. So all these things, they are called as a gateways only. So with the help of this gateway, you will be able to connect. Okay, this gateway can be, you will be able to connect from this gateway to this virtual machine one, right? Like this. And from the same gateway, you can connect to this virtual machine two, like this. So you can have this connect gateways to connect between these two machines. Of course, from here, from the virtual machine to the gateway, you need to have a physical connectivity, right? There has to be some kind of a physical wire should be laid down. And again, from here, what happened, right? From the router, again, you will have a physical connectivity here. So here, the physical connectivity is there actually, right? So it is not only one gateway, there could be a multiple gateway in between them actually. Suppose these two virtual machines are like in a distance of some 5-10 kilometers, right? It's not only one router, you can have multiple routers between them so that this machine can communicate to the other machine. Okay, between the like when there are more than one gateways or there are more than one routers which are there between them, right? These two machines can they can do a communication actually, right? Am I clear, sir? So now what happened is between these two machines, like you have set up a gateway. This whole thing, whatever you have set up, right? This we call it as a network actually, because you are connecting between these two devices, right? That we call a network actually. We call it as a network, right? Now, one thing is that, guys, whenever any kind of a devices, right? Let it be gateway or let it be virtual machine one or virtual machine two. Whenever these devices are getting connected to the network, usually what happened, all these devices will get a unique IP address. It gets a unique IP address. Say for example, for this gateway, it got an IP address like 192.168.0.1. This is the IP address which has been given for this gateway. So for this virtual machine one, you will get 192.168. What is it? Dot 0.2. And this will get 192.168.0.3. So as soon as any device comes under some network, they will try to get some unique IP address, right? The IP address is always unique. No two devices in the network, in the same network, will have a same IP address. You cannot assign the same IP address. 192.168.0.2 virtual machine 1 is having this IP address. The same IP address you cannot have in the virtual for the virtual machine 2. If there are if you set it out, what happened, right? It will throw error saying that it conflicts with the IP addresses, because already a device with some device has already used this IP address. So you cannot assign the same IP address to this device. Like that, it will throw error when you try to assign the same IP address. So hence what happened, in the same common network, you cannot have the two devices with the same IP address. It will not allow you to allocate that same IP address. Am I clear, sir? So now what happened, right? Now, whenever you come across with the devices, always what happened, that you will be able to get a unique IP address for each and every device. Now the thing is that a very common thing that, guys, when you get the IP address, usually what happened, you will be able to check the connectivity from one machine to other machine, whether I'm able to reach this from the virtual machine one, whether I'm able to check whether VM2 is available or not, whether I can able to connect it or not. So for that, what happened? The basically in the organization we use the ping utility or we use the ping command. So sitting in the virtual machine one, what I will do that I will try to ping to 192.168.0.3 like this. When you try to ping from virtual machine 1 to virtual machine 2 by assigning an IP address, so ping will give the status about whether this virtual machine is up or not, right? If it is up, actually what happened, right? You're going to get the response. You're going to get the response. You're going to get the ping response saying that that server is available, it's up and running. Say for example, if this machine is not available or it is down actually, or you're not able to connect it, then what happened? The ping will throw error saying that destination host unreachable. Like this, you're going to get an error actually, right? Or else you will get something like request timeout. Like this, you're going to get an error, right? If you are not able to communicate, if you're not able to ping from one machine to another machine. Am I clear, sir? So now the thing is that guys, actually that, yeah, of course, like what happened whenever you have the devices, every device will get a unique IP address actually, right? And we whatever the network we are connected, guys, this is something like it's a physical network actually. This is a physical network because why I'm saying physical network, because that from one machine to other machine we are connected, we have connected with the dedicated like wire actually, which is a physical wire. So with the help of the physical wire we are getting a physical network. You are getting actually, we're getting a physical network, right? But the thing is that guys, in today's digital world, right, like you cannot work only with the physical network actually. You will come across with some other networks also, like for example you come across with something like a virtual network actually, right? Virtual network, right? Or in the virtual network you might have come across something as a wireless actually, wireless network, right? Wireless network, for example, you know about your Wi-Fi device, right? Wi-Fi device is a wireless network, right? Right. So without the wire you can able to easily connect to your to the server actually with the help of a Wi-Fi device actually. So usually what happened, right, whenever we go with any organization, every organization what happened, right, they have their own data centers, you know. Every organization will have their own data center like this is the data centers. And in the data centers what happened, guys, there are so many servers which are there in the data centers. Servers are there. These are the servers like this. Hundred thousands of servers are there in data centers. And also what they do that they will try to maintain a lot of routers and switches. They will try to maintain it, and they'll also have some kind of a storages actually. Lot of storage are there. All these different hardware devices or network hardware devices actually, they're connected to each other actually. They're connected to each other. And how they're connected to each other? They're connected to each other with help of a physical network only. It means that there will be a physical cable will be going on where there will be a connectivity between all these devices in this data center actually. So this is the data center where you will have a physical network available inside, right? Suppose assume that a system administrator he is sitting outside here, right? He might be sitting outside here, right? He might be sitting outside here. Maybe he might be sitting outside from that data center, right? Now what happened, right? Here outside the office, what happened? Right? There will be so many switches will be there actually like this, right? So many switches will be there, and all the switches are connected via the network cable, right? Like this. These are switches actually, and there will be some big router will be there here, right? So this will be a router. Again, this router will be interconnected with many of the switches actually, right? Kind of this like a switches like this. This switch will be connected with the router like this, and this router will be connected with your main data center network, right? So that what happened, right? The traffic you can send from to inside your data center, you can send the traffic everything through this router actually, and it's not only one router. There will be multiple routers like this, and again all these routers are again interconnected. Everything they are all interconnected like this. Now what happened, right? There will be big switch will be there, guys, in the organization where what happened, right? There will be big switch will be there like this actually, right? Big switches will be there, right? And your PC, whatever the system admin PC, right? He will have a physical connectivity with this switch to one of the port actually, and this is and one of the port like this. And this switch, whatever you have, right, it would be connected with some other switches, multiple switches, which is already there actually. Now, an administrator, what he does, right? He will be sitting in his laptop here, which is connected to the network, right? He'll be able to easily connect to any one of this device which is there inside the data center, right? So what he will do basically, right, he will check the connectivity, okay, whether like I'll be able to reach to the server or not. So basically, he will use some utility in his terminal, like ping utility, to check it actually. Yeah, he is able to connect to that server, and later what happened? He will either use an RDP protocol or SSH protocol to connect to that server actually. So here what happened, all these things, whatever it's happening inside the organization, all these are physical servers only, or are physical network only, right? But what happened, but this is one case actually, but what happened, right? You will not be always be working on the physical network. You'll also work on some kind of a hybrid network also, right? Right. So hybrid network is a combination of something like a wireless network and a wireless network with physical network plus physical network. Right. So you could see that in the organization, guys, there are so many Wi-Fi devices are connected, right? In your company, so many Wi-Fi devices are connected, right? So what happened, right? Through the Wi-Fi device, what happened, right? What happened? An end user, he will be connecting with his Wi-Fi device. So he will connect with the Wi-Fi device. Through the Wi-Fi device, what happened, right? You will be able to connect to your router, and through the router, what happened? The router will be interconnected with this server which is there. So when you are communicating with that server, you will be using a hybrid network itself. It means that you will connect via the wireless network. From the wireless network, what happened? The communication happens finally further with the physical network. So you will find a lot of combination of this of this all this hybrid network, right, where you will be using some wireless network with the physical network. Everything we will be using in our organization, right? So it could be any combination, I'm saying. So usually what happened, right, whenever we are coming with the cloud actually, whenever we are coming with the cloud basically, whatever the network the cloud provides is all our virtual network actually. It's all virtual network, right? So with the help of this virtual network, you will be able to connect to your cloud actually. An end user can be able to connect to the cloud account, right? He'll be able to access all services, all the services. Even in fact, most of the tools, whatever we interact with the day-to-day activity, like for example, Docker in turn uses the virtual network only. Even your Kubernetes, it uses the virtual network only, right? So there are many services are there, guys, many tools are there which internally uses this virtual network only. So understanding the combination of this network is not but the hybrid network actually. So we in today's world, we all are working under the hybrid network only, right? You could see that at my home, I can sit at my home, and from my home I can actually connect to my office network, right? So at my home I'm having a wireless router actually, right? Wireless network I'm having. Okay, with help of a wireless router, I'll be able to connect it. So from my home, how I'm connecting, guys? How Rajesh can able to connect to the office network? So basically what happened, from the wireless network, what happened, right? Wireless network, wireless router. So usually what happened, right? Your organization has set up some VPN actually, right? So from your site, you connect to your VPN network actually. Means from your home, you connect to a VPN network. From the VPN network, you'll be able to connect to your organization network actually. Your organization network, you can be able to connect actually. So hence what happened, you will be able to connect to the network. You can sit in the organization network and you'll be able to access all these server or resources which is provided by your company. Whatever the servers or whatever storage are, right? You can sit at your home and you can connect and you can log into those servers actually. So how this is happening, everything, because we are working in a hybrid network actually. In the hybrid network, we are working actually. Right. So it is always important for all of us that we need to learn this hybrid network also. For example, if I want to learn about the Wi-Fi, I need to know about like how exactly internet works, like how this wireless network works actually, right? Suppose you take your wireless router, you should be able to know how to configure it actually. You want to troubleshoot it also. You want to go and change some configuration files for your wireless network. You should be able to know all such things, right? Because you're working in a hybrid network like environment actually, right? Similarly, when you're coming with the physical network, you need to know about the physical network, like how switches are working, how routers are working, how routers work. Not from very the core level, from very high level. I'm saying the basic level we should know actually. So when you understand all these devices very well, how to configure it, how it internally works, then you will be able to understand the whole like you'll be able to understand the whole concept of this network, no, hybrid network all about. Like you'll be able to learn in a very effective way, right? So the all these things, whatever you are using, right, we call this as a VXLAN actually, virtual LAN network. We say, right? Am I clear, sir? Okay, good. Now the thing is that guys, now the question comes that okay, Rajesh, we understood now all these things. Now the next question is that like how exactly this device communicate with each other. Like for example, we have seen that from one server to other server, okay, they are able to communicate with each other. How they are going to communicate each other with the help of a protocol actually, right? With the help of a protocol. So what is this protocol all about? What is protocol? So, guys, in if you try to go to the textbook definition, what they say that protocol is a set of rules actually, set of rules. When you create the network between the devices, between the devices, okay, between the devices, and when the devices want to communicate each other, they require protocol. So there are a lot of protocols are there, guys, right? There are a lot of protocols are available, right? There are a lot of protocols are available. Like for example, you have a protocol like TCP protocol, TCP/IP protocol, UDP protocol, right? SSH protocol, DHCP protocol, NFS protocol, FTP protocol, right? So there are hundreds of protocols like IMAP protocol, right? POP3 protocol, like that, right? We are having so many protocols are there. So usually what happen, right? These protocols are not, it is a set of rule where using this protocol, you will be able to communicate with from one device to other device actually, right? And usually who has designed these protocols? So the protocols were designed initially, they were designed by the Department of Defense America, right? DoD, we say Department of Defense America. They designed this protocol actually. So some of the finest network engineers, they sat and they designed it. Okay, and they try to come up with some kind of a protocol. Through a protocol, what happened at through a particular channel, you can able to send the data from one device to other device. That is how they created this protocols actually. And later many other protocol came to the picture, and all these protocols are managed and maintained by an sub-organization known as an IANA. IANA, Internet Assigned Network Authority. That is one organization where they manage it, and every protocol has some number actually. It has some unique number. Okay, what is that unique number? We will discuss about all these things later, but every protocol has a unique number actually, right? And every protocol is associated with the port number actually. It is associated with the port number. Like for example, right? So let me talk about the ports actually. So basically, what happened, guys? Right, in networking, we have 65,500, 3500 or 36, 36, right? Ports are available actually. Port numbers are available. Available, right? Available. Out of 65,535, from 1 to 1024 ports are being reserved actually. And after 1024, like 102425 to 65,500, 535 or 36, these ports are free ports, we say, or we call it ephemeral port. They are freely available. You can use it. So this 1 to 104 are reserved actually. For which they are reserved? They are reserved for using these protocols. So using these ports for communicating. All right. For some protocols actually. For example, SSH protocol. Right. It uses the port number 22. Right. Similarly, HTTP protocol. It uses the port number 80. So no other protocol can make use of this port number, guys, because this 80 is dedicated only to HTTP. Similarly, we have some of the DNS is there, which is the port number is 53 it uses actually, right? SMTP is there, it uses the port number 25, right? What else? UDP, FTP is there. What is the, where is it? FTP is there. It uses the port number 21, huh? Right? 21. Like that, every port, like every can say protocol has it uses internally some port actually dedicated port, and that dedicated port comes in this reserved category actually. Am I clear, sir? So as I said earlier, right, these protocols are used for communicating. Without the protocol, you cannot communicate between these two devices. These two devices can communicate each other with the help of a protocol only. So they might use a TCP protocol or they might use a HTTP protocol. Say, for example, you're having some web application here running here. Some web application here is running here. And some web applications running here in these two servers. If you want to do a communication with the help of these two web application, okay, you will be using a HTTP protocol to communicate actually. And the HTTP protocol uses the port number 80 in turn for the communication actually, right? So similarly, when you want to communicate each other with the help of an SSH protocol, it uses the port number 22. Similarly, if these two servers want to communicate with the help of a FTP server, assume that this server you'll be configuring as FTP server, and this server will be configured as an FTP client. If they both want to communicate each other, they can use the port number 21. And with the FTP protocol, and internally with the port number 21, they communicate each other actually. All right? Am I clear, sir? So now, so protocols are required for communicating as well as what happened, right? You need to have the port number also, right? Now the thing is that, guys, right? Whenever you are communicate between these two devices, what are the important things you should be there, or what are the important things which should be available when you are having whenever you are communicating between devices, what are the main important things which will always you read it? One is the network connectivity. There has to be a network connection, right? Right. The next important point is that actually the IP addresses. Every devices will have unique IP address. Yes, IP address should be there. There should not be any kind of an IP address conflict. It shouldn't be there. And the third important is that through which protocol they are communicating. So these are the main important things which you'll always keep in mind whenever the two devices want to communicate each other. Actually, am I clear, sir? So now, so guys, what happened, right? There are a lot of terms, terminals are there in networking. As I said earlier, also terminals are there which we need to understand. We need to learn it actually. For example, the terminology is something we might have we came across something as an IP address. What is IP addresses? And again, in IP addresses, we have sometimes a physical IP address, private IP address are there. So we need to understand what is physical and what is private IP addresses. Okay, we will come across with something known as a NIC, Network Interface Card. We call it the NIC card, NIC card, we say, right? NIC card. We will come across all these terminologies. We will also come across with something known as a subnets and subnetting. We will come across with something as a routers, okay, switches, routing, routing, route table, okay, route table association. Like this, we'll come up with a lot of terminology actually. So when you work with any platform, like when you're working on a cloud platform, you will come across with all this thing actually, right? What are the other things, guys? Actually, you will also come across with something known as firewalls. Yeah, definitely. DNS, uh, we call it the VPN, virtual private network, right? We will also come across with something known as a hub and spoke actually. Right? So there are so many terminals are there which will come across, like you will come across with some load balancer also will come across in that. What is a reverse proxy or reverse load balancer, reverse proxy, okay, forward proxy or forward proxy load balancer like this, right? Or HA proxy, right? Right? And also there are some other things are there, like will come across from the web server, will come across with something known as a DHCP, right? DHCP server, okay, NIS server, like this. You will come across very, very lot of terminologies will come across. We will try to learn all those terminologies, guys, actually. Am I clear, sir? Okay. So shall we try to spend another 15 minutes more, guys, to understand certain basic networking aspects? Let us try to understand some basic terminologies. So, guys, I might not be able to complete everything in 1 or 2 sessions. Maybe I think in another one, maximum, I think in 3 sessions, I'll be able to complete all basic networking. So, today is Monday. Tuesday and Wednesday, 2 more sessions I will take, guys, to complete this networking, basic networking. And from Thursday onwards, we will deep dive into the AWS networking. Like AWS networking, the first important thing which we'll be learning is a VPC, Virtual Private Cloud. Actually, that's the first service we will be learning it. Okay, we will try to learn in a very deeper way. And also we will see like how to create a VPC, how to set up a VPC, how you can create any kind of resources under a VPC. Actually, what is subnets, all such things we will be seeing in our from I think from Thursday onwards we'll start working on. But let us try to cover up certain things in today's session, like what is IP addresses. So basically, guys, what is an IP address? We know that, Rajesh, whenever any device come across with any network, automatically what happen, that device will get a unique IP address, we say, right? So unique IP address is, it is basically, we call an IP address is like a number actually. It's a number. IP address is a unique number which identify which identify the device in the network, right? So basically what happened, each and every IP address, it's a 4 octet value. It's a 4 octet value. And every IP address is represented by like this, x dot x dot x dot x. So here x means it is 1 octet. It means that 1 octet is something, it's an 8-bit actually, right? So, right. So this each IP address, it is a 32-bit. It is each IP address, it is 32-bit value actually. Because there are 4 octets are there in each IP address, and each octet is 8 bits actually. So 8 for the 32-bit. So each and every IP address is of a, if is of a value 32-bit value, right? And this 32-bit value, what we call is an IPv4 address actually. We call it as an IPv4 address. Similarly, we have an IPv6 address also. We will see about this IPv6 later, once we try to complete our networking part, right? When you try to complete the AWS networking part, at the end of the AWS networking, I will be explaining about most of the things about the IPv6 addressing mode, how we use it in the real time, how the IPv6 address are used now. But as of now, we will only rely or stick only to the IPv4 address only. So IP address, it is a unique number. It's a 4 octet value. right? Which is provided, which is given to each and every device, so that that device can be uniquely identified in that particular network. Actually, that is what we call it as an IP address. Right. Now the question might come, Rajesh, how exactly these IP addresses are assigned actually, right? For example, see, you're having a network devices, guys, right? We are having a network devices, right? And also what happened in your operating system, you are having a network stack which is enabled. Now, as soon as your system or a device, it connects to a particular network device. Say, for example, if you connect to a router or if you connect to a switch, actually, automatically what happened, right? These devices, they try to allocate an IP address for your device, actually. Again, it depends upon like on which network you are placed, actually, on which class of IP address you are working on. Based on that, what these devices will do, that these devices will try to allocate an IP address for you, actually. And it will be a unique IP address within that network, actually. That's how you have to understand in a very high level. Am I clear, sir? Am I clear, sir?
Yes.
Good. Very good. Now, the thing is that, guys, now assume that if you are working in your home network, suppose assume that I'm in my home network. So this is my home connection or this is my home network, guys. This is my home. This is my home connection, right? And here, you know that within my home, I have one router, right? I have one wireless router image. Right, this is my router image. I'll take any one. So this is your wireless router, or you can consider this as a wired router only as of now. Consider this as a wired router. Okay. Right. So this is home. Inside your home, you have a wired router which has been which you have placed it. And within your home network, what happened, guys? You can connect many devices actually. Like for example, assume that if you're having a laptop actually with you, you can able to connect your laptop with your device actually, right? And what are the other devices you can have? You can have something like phone, or it's not phone. I'll just say the iPad, right? And assume that you are having your computer desktop at your home. Okay, right? You will be even connecting. You will be having even these devices at your home where you have a desktop actually. And usually what happened, right? Since it's a wired network, what happened, right? Basically, you can able to connect. So you can have you can have a physical wire actually. You can connect from here to here to your device, and again from here to here you can connect with that with the router, wire, and also your laptop also you can connect with it. So this is not, but this is a physical wiring or physical connection you have set up actually. Right. Now the thing is that, guys, actually, as soon as you have a wired router, okay, which is there in that, automatically what this router will do, that it will going to assign an IP address for your devices. Right. For example, your router itself will have some IP address like 192.168.0.1. Right. And it will try to assign IP address for this 192.168.0.2. This is for 0.3 and 0.4. It's 192.168.0.3, and this is 0.4. Am I clear, sir? And here what happened, since it's home network, assume that you want to connect to the outside world, right? Then what happened, right? Usually what happened, you will come up with a lot of internet service provider. You call an ISP. Like in India, we have Reliance Jio, who are network service provider, right? You have an Airtel, you have an ACT broadband, right? There are so many network providers are there. So usually what happened, right? What this network provider will do that, like they'll have a modem actually. They got a modem like this. So this modem will be outside your building somewhere like this. So here what happened, this modem is from that service network provider. Say I have took a connection from the Reliance. So Reliance has this modem actually. So they set up the modem here. So your router will be connected to your modem actually. Like this. So whenever these devices they want to communicate to the outside world, okay. So what they do that they send the request to the router. A router will send a request to the modem, and modem will send a request to further to the internet service provider. And from the internet service provider, it goes. The request will go to the outside world. Right. This is how the communication happens. Okay. Since you are sitting at your home actually inside the home, these devices are connected and they will be given some unique IP addresses. Right. The unique IP address will be assigned to it actually. Right? And these devices, they can communicate each other, right? The desktop can communicate to the laptop device can communicate to your iPad, and you can communicate it. Now, see what is a basic rule for communication? Basic rule in networking. So the basic rule of networking is that guys, when sorry, I can say a device can communicate directly with other devices if that device are there in the same network. So two devices can communicate each other when those two devices are there in the same network actually. So it means that actually that this device can communicate and this device can communicate. They can communicate each other when they are the same network actually. Now, what do you mean by same network actually? Or how this device can exactly identify that I can able to communicate with this laptop? Similarly, how this laptop will know that I can able to communicate with the desktop? Because they have to be under the same network actually. Now, what do you mean by same network? See, if you see it actually, what is this IP address? 192.168.0.1. What is the IP address? 192.168.0.1, 192.168.0.4, 192.168.0.3. These are the IP addresses, right? This is IP address. But if you watch carefully, the first three octet, like 192.16.0, this is common actually everywhere. 192.160 dot 192.160 dot here also. So it means that all these devices are fall under the same network. This is what we call it as a network ID. So now what happened, right? What is an IP address? IP address we know Rajesh, it's a 4 octet, it's a 32-bit IP address. What you said is right. But IP address is not, but it's a combination of network ID and host ID, or we call it device ID. Host or device, one are the same. So always the IP address, the 32-bit IP address is a combination of the network ID and the host ID. Now, how we are going to understand whether what is a network ID and host ID? It depends upon the subnet mask. Suppose, for example, if I try to open a terminal here in my system, and if I want to check the IP address of my machine in Windows, actually, I will execute a command ipconfig. When you execute a command ipconfig, can you see here, guys? You will get 192.168.31.214. This is the IP address of my machine. Along with that, it is also giving an information about the subnet mask 255.255.255.0, and also it is also giving you the default gateway. So this always, guys, whenever you try to understand about the IP addresses or you want to understand about the network, you need to have these three information also always. So what are those three information? Whenever you are, oh man, what happened, man? Right? So what is it, guys? Whenever you're working on anything, you need to understand about what is an IP address of the device. That is one thing. Second is a subnet mask. And the third important thing is your default gateway. These are the three important things which is always required whenever you are understanding any kind of a networking thing. Like you should be aware of like what are this IP address, what is subnet mask, right? All such things you should be aware of. Am I clear, sir? Now here the thing is that, guys, now if you watch it carefully, right, the IP address in my server for my laptop is 192.160.31.214, okay, and the subnet mask is 255.255.255.0 actually, right? So when we execute ipconfig command, we got IP address, subnet mask, and default gateway. These are the three important values we got it actually, right? Now, for example, now assume that actually, like, I'll take what is an IP address? IP address is 192.168.31.214. This is my IP address. What is a subnet? Subnet mask, I'll just say SM, subnet mask is 255.255.255.0. So guys, I have a question here, right? Can you tell me the value of which is the position for the 255? What is the position value of this 255 value when it comes to subnet mask? What's the position value? So this is the first position value, right? 255. Second position value, right? 255. And the third position. So in three position, first, second, and third, you will find the value 255. Whereas here in the fourth position, the value is 0. Am I clear, sir? Now, what I'm trying to ask you here, that one question, that in the 255th position, wherever you are, wherever the subnet mask, where the value is 255 position, the corresponding value in, at the corresponding place in IP address, what are the values you'll find? Under the 255, 192 is there. Yes, that is what it is. Under 255, 168 is there. Yes, 168 is there. And under this 255, 31 is there. Right? Where exactly you are finding the zero value? So 0 is in a fourth octet, or is the fourth position. Under the same fourth position, when it comes to the IP address, the value is 214 actually. Am I clear, sir? So wherever you are finding the value 255, right, that we call it as a network ID. Wherever you are finding the value 0, right, under that, that is what we call it as a host ID or device ID. Right? For example, let me take one more example. Right? For example, one more example I'll take. Like for example, if my IP address is 192.168. What is it? 0.510 actually, something. And I'll take a subnet mask as 255.255.0.0. Now, right? Now the thing is that, guys, actually, what which are all the position where you will have the 255. So if you consider 255 in the IP address, which are all the positions? So here you are having a first position 255, second position 255. Only these two positions are the value 255, right? Whereas in third and fourth you have 00. So corresponding to the IP address, what is the value you're finding in the first position where there's a 255? So corresponding in the IP address, it is 192. Yeah, 192 is where you're having corresponding IP address. It is placed in that position. And for the second one, what happened, right? 168. Yeah, 168. What about the zeros actually? So zeros is there in the third position and the fourth position, right? So corresponding the IP address under the third position 0, what is the value you're having? You're having the value 0. And under the fourth position, you're having the value 10. So here, whatever the 255 value you're having, right, that we call it as a network ID. Network ID. And this one, wherever you're seeing the 0, this is nothing but the host ID. Am I clear, sir? Did you understand the point? Now, what we say that whenever you are having two different devices connected in the network, if the network ID matches us, the same network ID match, then it means that those two devices can communicate each other. So if you come back to the diagram, and if you see that what in this case, like in this case, so in our case, like in this case, like for example, assume that this is the IP address, okay, and assume that for in my network actually, okay, in my network, the subnet mask is 255.255.255.0. This is my subnet mask. Assume that actually. So in our case, what happened? In this case, what happened right here? What is an IP address you're having? You are having, according to a diagram, you are having IP address. I'll take one IP address of one device. Like for example, I'll take this desktop IP address 192.168.0.2. Yeah. 192.168.0.2. And what is the subnet mask? Or 255.255.255.0. So now what I'm saying that which are all the position where you're having 255 value. So 255 is in a first position, second position, third position, right? In the subnet, you'll find these three position or three octets are not but 255 value. So corresponding the IP address, what are the positions? So under this, so under that under the IP address, it is 192 where you are having in this first position, and the second position is 168, and in the third position is 0 actually, right? And now what about the 0 value? Oh, it is there in the fourth position. So corresponding IP address, what is the value which you are having in the fourth position? It is 2 actually. So now this 255, whatever you're talking about, this is nothing but your network ID. And this is nothing but your host ID or device ID. So as I said, that network IP address is a combination of network ID and host ID. So in our case, the network ID is 192.168.0. This is the network ID. And the host ID is what? The value 2 actually. Now, whenever two devices or three or multiple devices are having same network ID, then they'll be able to communicate each other. If the network ID differs, they cannot communicate each other. Like for example, if you are having some other device like which is having 192.168.3.10, you are having a device with this actually, right? This device, it cannot communicate with the other device which is having 192.168.0.2 or 0.3. Like for example, here, firstly, I mean like this, if you're having one more device in this network which is having that 192.168.3.4, they cannot communicate with this device actually because the network ID is different actually. Am I clear, sir? So I hope that you understood it, like how they're able to communicate each other, because whenever in the same network, whenever multiple devices can communicate each other when their network IDs are same. If the network ID differs, they cannot communicate each other. This is the basic networking communication. I mean, this is the basics of networking, that the network ID should be same. Am I clear, sir? Okay, guys, with that, we are going to stop today's session. Right, we will continue from this diagram onwards because we need to further discuss many other things actually, right? Clear, guys? Okay, so
Yes.
let me know if you have any doubts so far. Okay, so in the next session, guys, what we're going to understand is that in the next session, tomorrow morning, we will try to understand about this itself. Like for example, you will try to we will continue from here itself actually, and also like we will be communicating, we'll be understanding about what is subnet and subnetting all about. That we'll be discussing tomorrow session, right? And we'll also try to design certain things. Like for example, in our company, we are setting up a network. Suppose assume that in our company, we are setting up some like 1,000 devices we want to connect in our network. Like what could be the range of IP address you'll be assigning it, or what is the what is the class IP address you choose it. So what is the class of IP address? So in tomorrow session, we will be learning about what are the different classes of IP address. Classes of IP address. That we have to learn first. And then like when you are designing your network, right? How you are going to choose which class of IP address, classes of IP address which you will be using. And also like how we will be doing the subnetting actually. This is what will be tomorrow's agenda. So what is the best design you are going to do it so that you will be able to, you're going to take a range of IP address where you can accommodate to give the IPs for your 1,000 devices. Similarly, tomorrow, if you're having some 10,000 devices or 1 lakh device in your company, how you're going to create a network where you can accommodate so many number of devices actually, right? Because each and every device should be given a unique IP address actually, right? So all such things we'll be discussing, and also we'll be discussing about what is a private IP and public IP. So all such concepts we'll be learning in our tomorrow session. Am I clear, sir? So with this, we are going to stop, guys. Today evening, let us meet at 7 p.m. IST, right? Let us meet for the Git session tomorrow. Today, 7 p.m. We have a Git session. Guys, one more thing actually, like I'm planning to complete the Git in this week, in the next 7 days. Sometime what happened, right? Some days maybe I might call more than one session. I might do more than one Git session because I have to complete by any cost. By Sunday, I need to complete the Git actually, so that from Monday onwards we can start with Docker actually, right? So if I'm not able to cover in these 7 days, like I might call, I don't know how many people will be available. I might call a few people to come in some time where I'll be taking an extra thing in the Git actually. Other people who are missing the session, I would request them to go through the recording, right? Because if I start doing every day, right, maybe I might need more than 7 sessions to complete it. I'll try to at most try to complete within 7. If it is taking more than 7, then I would request that I'll be taking more sessions, right? Maybe from Wednesday onwards, you will see that I might call you to come at afternoon time. Some people I'll check who are all available. Like I will call them and you please attend for 1 hour session so that I will be slowly covering a few of the things so that no, I'll be able to complete the whole kit by Sunday actually. Right. My target is to complete by Sunday so that from Monday onwards, next week, Monday onwards, we can start with Docker. So Docker, I need a minimum 15 to 20 sessions I need to complete it. Okay. Docker is a very big topic. So I need minimum 20 days to complete it. Once the Docker completes, like we will be going with the Kubernetes actually. But again, when I start with the Docker guys, I need some extra class also to take about the build servers. Yesterday you saw, right? I have to explain about what are the build servers all about. Like I'll be explaining about the Maven build server, MS build server, right? Node.js build server. Like that, I need to discuss about that build server also. Parallelly, I will be doing that also, right? Plus, I will be taking about the SonarQube and Nexus and JFrog. This also have to take it. So build server for me, it will take around 4 sessions. SonarQube, 2 sessions. Nexus, 2 sessions. JFrog, 2 sessions. Yeah. Plus Tomcat server. So Tomcat server, 2 sessions like this. When I try to cover all these things, guys, this is the basis for you to learn about the entire build server architecture. You need to have all these things when you are setting up your whole project, right? You need to have all these things. So once we complete all these things, once we continuing with the Docker actually, then I think that I'll be ready to execute some projects actually. With the help of a pipeline, I'll be able to execute the projects actually. This is what I needed actually. So once we complete this build server, everything, we are ready to run, or we are ready to create any kind of a pipeline projects actually. So that I will be explaining about the pipeline. I'll be explaining about something about the Jenkins, how to set up the Jenkins there and there itself. I'll be explaining about that, how to set up the SonarQube, how to set up the build server, Nexus, JFrog, Tomcat server, everything, and then like we will see how the pipeline flow works. This is what I need, right? I knew Git would have completed. Git also will be integrating with the pipeline. So along with the Git, may all these things, build server, SonarQube, Nexus, JFrog. So what I'm saying is this also I want to parallelly run when I am taking Docker actually, because Docker is a separate topic. Docker is for the containerization, but Docker intern is also like a build only. It's like a build only. You are building a Docker image, right? It acts like a build server only, right? But before that, what happened? That I will be taking a basics of what is this build server all about and how to set up the Maven build tool, how to build like any kind of a Java based project using Maven build tool or Gradle build tool. Similarly for .NET based project, MS build. Similarly for the Node.js application, we need to have a Node.js build server actually. Similarly for the Python, similarly for the other programming languages, right? What we have, right? So we need to set up different build servers actually, like that. And plus SonarQube is something which will be using for the code quality gate checks. Nexus is for the Artifactory. JFrog is for Artifactory. Tomcat is for your hosting your application, right? We call it an Apache Tomcat server. It's our application server. Right. Similarly, we'll have a web server also, like Apache web server is there, Nginx web server is there. Even that also I have to discuss. So it's a quite lengthy session, guys, which we will be taking in our upcoming month, right? Next month we will be covering many things. Is it fine, guys? So with that, let me stop today's session. So next month, guys, December will be quite challenging for all of us because we will be learning many things. I'll be pinching in a lot of topics parallelly, right? So that we'll be learning in a very faster pace. Right, that's what my intention. So parallelly, I have to run this also. Parallelly, I have to take all these topics also. Okay. Okay. Let me stop the recording.